All right, guys, so I'm going to do a study guide with you here. Let's go ahead and begin. So with number one, it says that we're to find the relative extrema. So it doesn't really matter to me whether you want to use the first derivative test or the second derivative test. Either way, so long as you find the extrema, you're good, okay? So the process that we're going to go through then is we're going to find the derivative of our function there. We're going to set that equal to 0. And when we solve for x, that will tell us what our critical values are. Okay? So we have x equals 0. And if we set this one equal to 0 and solve, we'll get 4/3. Okay? So those are our critical values. And that's where we could possibly have some relative extrema. So now I think what I'm going to go ahead and do is I'm just going to go ahead and do the I'll do the first derivative test this time, and then maybe on the next example I'll do a second derivative test. Like I said, it doesn't matter which one you use. So for first derivative test, what we do is we put our two critical values on a number line, and we pick numbers in between them and plug those into the derivative to see whether the slope of the function is positive or negative at that point. So over here, if I were to pick like -1, and here I would pick 1, and over here, this is about 1.3, so I would just pick maybe 2. So let's go ahead and plug these numbers in. So if I plug in a -1 to my derivative, you could plug it into this, but I kind of like to use the factored one. So if I plug in -1 here, I've got a negative, and if I plug in a -1 here, I get a negative, and two negatives make a positive. Or you can actually, like I said, just plug it into the original, get a number, and see if it's positive or negative. If you plug in a +1, you get a +1 here, but it's still a negative here. Positive and negative make negative. And then finally, if you plug in a positive, you get a positive here and a positive here, making a positive. So what's going on then is my function is increasing until we get to 0, and then it's decreasing until we get to 4/3, and then it's increasing once again. And therefore, we know that f of 0 is a relative max, whereas f of 4/3 is a relative minimum. Now, on your actual quiz, they may want you to find the y values. So, matter of fact, let's see. Yeah, I don't know. It just says find the relative extrema, so that makes me think just y values, but they might want like a whole point. So let's go ahead and work with that a little bit, just in case. So so we knew that f of 0 was our relative max, right? So I'm going to put RMX there. And we know that our f of 4/3 was our relative min. So I'll put RMN for that one. And what I'm going to do is I'm actually figure out what the y values are now by plugging it into the original function. So if you plug 0 into this, what you're going to get is pretty easy. That's -1. So here's my relative max, right, as a point. So, you know, I don't know if they're going to want you to put the y value or if they're going to want it as a point, but it'll be one of those two things. Over here, you can use a calculator probably on this test. I don't really see a problem with you using a calculator on the exam or the quiz. I mean, it's take home, right? So mine as well. But I don't know. It's pretty easy to just go at it otherwise. So we're going to work this out. So that's going to be 64/9 if we cube it. No, I'm sorry. It'll be over 27. And then we'll have 2 being multiplied by 16/9. So what we're going to need is we're going to need a common denominator here. This is going to be 32, right? So to get our common denominator, I need to multiply this one by 3, and I need to multiply this one by 27. Okay. So that results in the following. We still have 64 over 27. Now here we're going to have 96 minus 96 over 27, and then minus 27 over 27. Gosh, it's still an awful lot of calculation we have to stress around with. Like I said, if you guys just want to use a calculator, I'm okay with that. So it'll be negative 123, we're going to put 24 on there. I'm getting negative 59 over 27. Who knows if I did it right, honestly, but it's just the fraction issue there. But so you can write your answers then as points, right? So that's the main point I wanted to make here. So we have a relative max at 0, 1, or negative 1, and we have a relative minimum at 4/3, comma, negative 59 over 27, if you want to write it as a point. So there you have it. Okay. So let's go ahead and move along here then. The next question says, on what interval is the function increasing? So to answer that question, really we just need to come back to the number line that we drew earlier. So if you don't recall, we had a critical value at 0, we had a critical value at 4/3. And what we discovered was that on the interval from negative infinity to 0, it was increasing, then it was decreasing, then increasing. So on what interval is this function increasing? Well, anything from negative infinity to 0. It's increasing, and also from 4/3 on up into infinity, it's increasing. Whereas the next question over here, where is it decreasing, would be this region here. So you can't see the whole question right now. Maybe I can minimize this. No, I can't do that right now. But anyway, number 3 says, where is it decreasing? So that would be from 0 to 4/3. Okay. Next question. On what interval is the function concave up? Well, so now to answer that question, we need to do something else. Okay, we need to find the second derivative at this point. Okay, so let me see. What was our original function? Hey, Chris.
Yeah. Although, like, oh, he left and the lights off.
Yeah, the video will turn out better if the lights are off. All right. So let's see here. Our first derivative was 3x squared minus 4x, right? Now, when we want to know about concavity, we need to find the second derivative. So that would be 6x minus 4. Okay. So first thing we want to do is, you can just go around that way. Thanks, Chris. We're going to set this equal to 0, and what that's going to do is that's possibly going to help us find a point of inflection, right? So if I add 4 and divide by 6 and then reduce, I should end up with 2/3. So this is possibly a point of inflection. Okay? So I'm going to put 2/3 right here. And what I'm going to do is I'm going to do the number line test. But remember, this time I'm going to be plugging it into the second derivative because I'm testing intervals of concavity. So to the left, 0 is a pretty easy number to plug in. So if I plug in 0 to my second derivative, I'm going to get a negative outcome. And then I'm going to pick a number to the right of 2/3. We'll say 1. So if you plug in 1, you're going to get a positive. So what's going on here then is we have concave down on this whole interval here, and then concave up on this whole interval here. And therefore, where those two pieces would join would in fact be a point of inflection. Anyway, where were we? We have a point of inflection then is going to be at 2/3. So to answer, I think it was question number 1, 3, I don't remember anymore. What interval is it concave up? Well, that was from 2/3 on up into infinity. And for number 5, it's asking us where is it concave down? Well, that was from negative infinity on up into 2/3. Okay? And then, of course, finally, we have the last question here. Where are the points of inflection? And that was at 2/3. Now, we want to explain why that is. The explanation for this would be because f double prime changes signs at that point. That's your reason. Okay? So, that's one whole problem there. The next one, I don't think we really need to do the entire thing because it's really just a repeat. Whenever I initially planned this study guide, I intended to do one for you and let you guys do the other, so it's just kind of repetitive. So I won't do the whole thing, but what I will do is I'll show you another option about how you can approach this question here, finding the relative extrema and explaining your answer. And actually, I didn't do that on number 1 either. I didn't talk about explaining how I know it was a min or a max. That's kind of important for your quiz as well. So I'll do 2 new things with this one question here on number 7 before I move on to the other stuff. I'm going to show you how to use the second derivative test to tell if it's a relative extrema, and also how to explain that in the form of an answer there. So first thing we do is we find our derivative. Set it equal to 0. And we're going to factor to solve. Setting this one equal to 0, we get 0. Setting this one equal to 0 is kind of interesting. I'll show my work here. You're going to minus the 1 on both sides. Divide -1 on both sides. And don't forget, when you take a square root, you always get a plus and a minus. So we actually end up with 2 answers there. So now we have a 0 and a plus and minus 1 for a total of 3 critical values. Now, like I promised you this time, I'm not going to use the first derivative test. I'm going to use the second derivative test. So, to do the second derivative, basically we take the second derivative. So if I take my second derivative, it's going to be negative 12x squared plus 4. Okay? And we're just going to plug these numbers in. So let's find out what y double prime of 0 is first. So if I were to plug in 0 into my second derivative, I'm going to end up with positive 4. So I end up with a positive number. If I plug in -1, well, the square is just going to make it a positive 1, right? And positive 1 times -12 is -12, plus 4 is -8, so you end up with a negative. Plugging in a positive 1 is going to do the same thing because we're squaring it, so we get negatives there. So here's the deal. What that means is that this graph is concave up at that critical value, which means that that critical value gives us a relative minimum. Graph is concave down on both of these ones, so the critical value for those ones gives me a relative max. So, once again, I'm going to write it as though it were a point. We have 0 and -1 and 1. And now we need to find the y values for where we would have those extrema. So once again, to find your y values, you plug it back into the original. So if I plug in 0 here to the original, I'm going to get 3. If I plug in -1, let's see, it's going to be -1 plus 2 plus 3. I believe it's going to come out to be 4. And then if I plug in 1, I think I'm going to get the same exact thing, I believe. So what that means is, in this case, this is a relative minimum point, and both of these are relative maxes. Okay, so we have 2 points where there's a relative max, 1 point where there's a relative min. Now, I still haven't explained my reasoning. Now, since I used the second derivative test, my explanation is going to be it's going to go one way. Now, if I wanted to go back to the other one, I could show you how to explain that as well. But for now, let's focus on this one. So here's what I would say for this one. This one is a relative minimum because f double prime is positive at that point. So I'm running out of board space here, so I'm just going to draw it up here. I'm going to put since f double prime is positive, greater than 0, at that value. Now, if you were doing the first derivative test, what you would do is you'd say because the slope goes from negative to positive at that point, or you say the first derivative goes from negative to positive. So you would word it differently if you used the first derivative test. As for these ones here, your explanation would be since f double prime is less than 0 at that value. But once again, if we're using the first derivative explanation, which honestly I think is how it's going to be on your guys' test, what you would say is that the slope goes from positive to negative at that point, or y prime goes from positive to negative. So there's 2 ways you can explain it based on which test you used to find the relative extrema. So that's that. I'm going to go ahead and skip over the rest of them because the rest of them are just kind of repetitive. But let's go ahead and take a look at number 13. It says the graph below is of f prime. Identify the intervals of increase and decrease. Now, a lot of you guys were gone on a field trip on a day when we did this. What we did was, and I didn't have a video, unfortunately, so pay attention if you were gone on that day where you missed the lesson. I think it was the day we did 5.6. I think it was like Monday, if I'm not mistaken. Anyway, what we did in class was we graphed these things on graphing calculators. Okay. Now, if this is a graph of f prime, okay, so that's important to pay attention to. This is not a graph of f. This is a graph of f prime. Now, here's what we know about this region right here. Let me, if I can, give myself a bigger highlighter. Here's what we know about from here to here. F prime is above the y-axis, which means that f prime is positive there. Oops, I don't like that. So f prime is greater than 0 on that interval there. And the same thing holds true for over here. Over here, I kind of want it purple. I mean yellow. All right. Over here, f prime is above the x-axis, which means that f prime is positive there. Okay? So, over here we would say that, did it again. Over here we would say that f prime is greater than 0. All right? Now, here, f prime is below the x-axis, So on that interval, we would say that f prime is less than 0. Okay? But what about right here where it switches from greater than 0 to less than 0, and also over here where it switches from less than 0 back to greater than 0? Well, at those points, f prime actually equals 0. Okay? So the question is, identify the intervals of increase and decrease. Well, identify the intervals of decrease of f is what I should have said here. So this is a graph of f prime, but I want to know what are the intervals of increase and decrease of f. Okay. Well, the yellow regions are where the slope is positive. Now, some of you guys might be really confused right now because you're thinking, Mr. Bailey, that's a negative slope. I understand that what you're looking at here is a negative slope, but remember, this is a graph of f prime. And since this is a graph of f prime is positive when it's above the x-axis, right? So if f prime is positive, that means the graph of f, which we can't see with our eyes right now, actually would be going up. It would have a positive slope there. So what we would say then is that f is increasing from negative infinity up to negative 2, and from 2 on to positive infinity. Okay? We would say that f is decreasing on the green region there, because in the green region, my derivative is negative. And when the derivative is negative, the original function is decreasing. So from negative 2 to 2, it's decreasing. Okay? So there's that. Let's take a look at another one here. Okay. The graph of g of x is given below. Now this is a graph of g. This is not a graph of g prime. This is just a graph of g. So we're looking at the original function itself. The graph of g of x is given below. For each point on the graph that's indicated with the big dot there, we want to complete the blank. So for instance, f of negative 4, f prime of negative 4, and f double prime of negative 4. What needs to go in these slots is either an equal sign, a less than sign, or a greater than sign. Is it less than 0, equal to 0, or greater than 0? So let's go ahead and begin here. So f of negative 4. Well, here's where the function has a f of negative 4. Now, the y value at that point, would you say that's equal to 0, less than 0, or greater? Is less than 0. Okay? Now, some of you guys might be getting a little bit concerned here because you might be wondering, oh, I forget about less than or greater than. Just remember, Pac-Man always wants the bigger number. So if 0 is bigger, that means that f is less than, right? All right. Now, the next one, f prime of negative 4. That's a slope. My tangent line is going upwards, right? This thing is sloping upwards. And when that happens, that means your slope is positive. So this derivative would be greater than 0. And as for f double prime 4, that's for concavity. Okay? I would say from here all the way up to somewhere about in here, it's concave down. So I would say that that's less than 0. So we're looking at the y value, the slope, and the concavity. Okay? Let's look at another one here. So f of 2.5. 2.5. That's this point right here. Yes. All right, at that point, I would say that the y value is positive, right? I would say that the slope is positive because it's sloping upwards. And I would say that the concavity, concave up, is positive. They're all positive. How about at 1? At 1, that's right here. At that point, I would say the y value is negative because it's below the x-axis. I would say the slope is 0. It actually equals 0 because we have a flat tangent line at that point. And it's still on a concave up interval, so I would say that the second derivative is still positive there. Okay? Let's go ahead and take a look at the next one. 1.5. So at negative 1.5, that would be, I don't see negative 1.5 as being highlighted on this graph. I mean, we could do it. It might have been a typo. I think maybe I meant to put 0.5, so what I'll do is I'll correct the study guide before you guys look at the thing here. So what I'm going to do is I'm going to treat this like 0.5, okay? Okay. Need to actually scroll down before I do that. So I'm going to say these are zeros. 0.5, 0.5, 0. And that's like right here. So at that point, the y value is positive. It's above the x-axis. The slope, the graph is going downward at that point, so that would be a negative slope, so less than 0. The concavity, as you can see here, I would say that the graph is concave down up to here, and then from here over it's concave up. And so at that point that we're looking at right now, right here, I would say that's a point of inflection, which means that the second derivative would actually be equal to 0, would be the best estimate. Okay? The last one, which I don't know if you guys can see it or not. Let's see. F of negative 2, that would be this point here. So at that point, the y value is greater than 0. The slope is 0. The concavity is less than 0. Okay? All right. Let's see. What else do we got here? All right, 2 more questions. All right. Let's go ahead and jump on into number. I'm going to skip 15 for now. I'll come. I guess I could do it. Now, I'm not going to open up the blue book. It's a bit of a hassle, but I know what the question is. So it's something like they give you a chart, right? Throw some random x values on here. Okay. And they ask you a question. Let me see, what would be a good one? Is there a value C on the interval (3 to 5) such that f prime of C is equal to 3, and then they ask you to explain your answer. Okay, so this is an MVT question, a mean value theorem question, but it's an FRQ, a very common FRQ question, and so I wanted to get that on our quiz. On your quiz, this one's a free response. It's not multiple choice, so you're just going to write this answer on the back of your little bubble sheet. But anyway, so how do you do this one? Well, first of all, you have to remember what the MVT is. The MVT is something that tells you that the instantaneous rate of change is equal to the average rate of change on the interval that you actually care about, which in this case would be 3 to 5. So that's my A and that's my B. Okay? Now, we're going to go ahead and plug these things in. F prime of C is equal to, if we're going from 3 to 5, it would be 5 here, 3 here, 5 here, 3 here. Now, f of 5 is 8, and f of 3 is 2. So we would have, I have to bring my work down here, I'm running out of space. So we would have 8 minus 2 over 5 minus 3, which is 6 over 2, which is 3. So the question was, is there a value of C on the interval from 3 to 5 such that f prime of C equals 3? And f prime of C does equal to 3 on that interval. And so the answer is yes. Okay? Now, it does ask you to explain. So I'm going to show you guys how you would write your answer here in order to get full credit. All right. So what you would have to do is you would have to, let me clear all this stuff off. Here's how you'd write your answer. You would say, yes, since the function is differentiable, and f prime of C is equal to f of, what was it, 5 minus f of 3 over 5 minus 3 equals 3. I skipped some steps, but here, that's okay. It doesn't matter. I didn't show the 8 minus 2 thing. You don't need to. Here's all you need to do. You need to have your answer. Yes. Here's my explanation. This is very important. You guys have to say that the function is differentiable. Now, I didn't do that when I wrote my problem up here, but it will say it on your guys' actual quiz. And the reason for that is because if the function is not differentiable on the interval, then you can't do the MVT. So you have to state that it's differentiable. That is a point for sure. Okay, if you don't state that it's differentiable, then you will actually lose half of the credit. So you have to say yes because it's differentiable, and you have to show the work of how you calculated 3. So they should be able to see the math aspect of the mean value theorem. They should see the instantaneous rate of change, they should see the average rate of change, and the final answer there. So there are basically 2 big things you need to have. You need to state that it's differentiable, and you need to show your math work. This, you have to say yes, obviously. So, I mean, but it's kind of like obvious. So these 2, though, are where the points really lie. Okay? So now, just so you guys know, the answer could come out no. You know, I mean, in the table, all I had in the table was from 3 to 5, right? And if it turns out that you couldn't have any other combination of points within that interval that would ever give you 3, well, then you would say, well, apparently not. I mean, it's hard, or you would say, we don't know, right? So, but usually the questions almost always turn into a yes on that. That's how they're kind of designed. They just want to see that you actually know what the mean value theorem is. Okay, last question I'll go over with you guys, number 16. All right, so this is kind of like the table question that we did earlier in the week. I tell you some information about a function, and you got to come to some conclusions about it. So I tell you a y value, I tell you the slope, and I tell you the concavity at that point. So here's what we know. I've got a point at -2, 7. -2, 7. My slope is 0 at that point. So I'm going to draw a dotted horizontal line to represent a horizontal tangent line. And what that usually means is we have a minimum or a maximum at that point, right? Now it tells us here that the second derivative is -4. So if my second derivative is negative, I've got a concave down graph at that point. So if that's going to be a min or a max, and this is concave down, it would look something like this then. There's probably more to that graph, but that's all that I know based on what they told me. Now I have to go through and decide, are these statements true or false? A, f has a critical value at x equals -2. A critical value is when the derivative is 0 or undefined. So is the derivative 0 or undefined at that point? The answer is yes. So we would say true. I guess true is what they want. F has a relative max at -2. Is that a relative max? True. F is concave up at -2. That's false. It's concave down. F has a point of inflection at -2. That's false. Be careful there. People get critical values and points of inflection mixed up. A point of inflection is where the concavity goes from concave up to concave down or vice versa. In this case, we're not changing concavity. It's concave down on the left, it's concave down on the right. So the concavity did not change. So the answer to that one is no. It's false. Last one. F prime of -2 changes from positive to negative at -2. Well, let's see. What's my slope on the left? Positive. What's it on the right? It's negative. So did my slope change from positive to negative at that point? The answer is yes. So that's also true. All right. So that's that. That's your guys' quiz. Hope the video was helpful, and we'll see you guys in class tomorrow.